Hey, it's Mr. E here, and our aim for this video is how do we simplify radical expressions when the index equals 2? Okay, so first, a radical is made up of two parts. It's made up of the index, and it's made up of the radicand. The index tells you what root you're in. So, you could have a square root, you could have a cubic root, you could have a fourth root, and so on and so forth. So the index is this part over here, referred to as n, and it just tells you what root you're in. The radicand is what is under the radical. So in this case, k is what's under the radical, or what we call the radicand. Today's video will deal with expressions when the index equals 2, or square roots. So when you're in index 2, they don't usually write, 2 and then the square root symbol. It's just the radical, and there's an invisible 2 there. So if there isn't an index, you just assume that you are in square root. Okay, so what is a square root? A number that produces a specified quantity when multiplied by itself. That's a square root. A number that produces a specified quantity when multiplied by itself. So 10 is the square root of 100 because when multiplied by itself, it produces 100. So what is the square root of 9? Well, another way of asking that is to say, what number multiplied by itself gives you 9? So that number, the square root of 9, is equal to 3. Because 3 times 3 is 9. So that's what a square root is. It's a number that produces a specified quantity when multiplied by itself. What would be the square root of 10? Well, sometimes students mistakenly say that the square root of 10 is equal to 5. That is not true. Think about it. 5 times 5 is not 10. So 5 is not the square root of 10. So what is the square root of 10? Well, we need our calculator for that. The square root of 10 is approximately 3.162. So the square root of 10 is approximately 3.162. 3.162 multiplied by itself is approximately 10. Let's see what we get exactly. See, it's approximately 10. You don't get an exact 10 because we rounded this number off here. Okay, so as you can tell from this little exercise here, we have perfect squares, like 9, for example, is a perfect square because the square root is not a decimal. And then you have certain numbers that when you take the square root, you don't get a natural number. Those are not perfect squares. So what are the perfect squares? Well, we got 1, 4, 9, 16, and so on and so forth. And here's how you derive them. You just go through the natural numbers and multiply them by itself to derive the perfect square. So for example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on and so forth. And that'll be a way to derive the perfect squares. Okay, so how do we simplify a radical in index 2? Remember I said earlier, here we know we're in index 2 because there's an invisible 2 there. So it says express radical 72 in simplest radical form. So here's how we do it. We're going to use the largest perfect square that goes into the radicand. So go to your perfect squares and find the largest perfect square that goes into 72. We know 4 goes into it, but we want the largest. That would be 36. So we can rewrite radical 72 as radical 36 times radical 2. So we use the largest perfect square that goes into the radicand to factor the radicand. Now we just simplify the perfect square. Radical 36 is 6, so we get 6 radical 2. That's our final answer. Okay, in case you're wondering, what would have happened if you use 4? Well, you could use 4. It's just going to be more steps. So radical 72 is equal to radical 4 times radical 18. So this would simplify to 2. But now you have to simplify radical 18. So radical 18 could be simplified as radical 9 times radical 2. Radical 9 is 3. Bring down the radical 2. Bring down the 2. So you got 2 times 3. That's a times symbol. I'm sorry, it looked like a decimal symbol. It's 2 times 3. So 2 times 3 is 6. You get 6 radical 2. So you get the same thing. You got the same thing in more steps. That's why I prefer that you just find the largest perfect square that goes into the radicand, and then you could just do everything in 2 steps. Okay, so here it says express radical x to the 7th in simplest radical form. So here we got radical x to the 7th. What you want to do is factor out. That should say factor out, not factor hour. Let's fix that. Factor out the largest even power of the radicand. So that would be x to the 6th. So x to the 6th times x to the 1, that gives you x to the 7th. So that's how you simplify radical expressions. When you have like a variable raised to a certain power and you want to factor that radical, you just factor out the largest even power of the radicand. Okay, so let's just rewrite this as separate radicals. Now we want to simplify the radical with the even exponent. Remember that rule we looked at in the other video? X to the mn is equal to the nth root of x to the m. Remember that video? So let's use that rule to simplify the radical with the even exponent, which is this over here. So this radical x to the 6th, and then there's that invisible 2 here, that would be equal to what? X to the 6 over 2, which is x to the 3rd. So we get x to the 3rd times radical x, or just x to the 3rd radical x. That's our final answer. All right. So with the variables, you just want to factor out the largest even power of the radicand. Example 3. Express radical 175 x squared y to the 3rd in simplest radical form. All right, so first, rewrite as separate radicals. And now we're going to simplify each radical. So we're going to simplify radical 175. We're going to simplify radical x squared, and we're going to simplify radical y to the 3rd. Radical 175, that simplifies to 5 radical 7. Radical x squared. So we're going to use that rule. Remember that rule from before? Here, let me put it here. We're going to use this rule to simplify radical x squared, and that's going to give us x. Right? Because there's an invisible 2 here, and that's going to be equal to x to the 2 over 2. That's sloppy, right? I should rewrite that. So radical x squared is x to the 2 over 2, which is x to the 1, which is just x. Okay, now we're going to simplify radical y to the third. So go back to example 2. How do you simplify this expression here? Well, factor out the largest even power of the radicand. That would be y squared. And then radical y squared, that's just going to give you y. So you get y radical y. Let me get that out the way. Let me see if I could zoom into this a little bit. Just so that you could see it better. Okay, let's continue. The next step is to join the radicals as a single radical and leave the coefficients outside. So let's join the radicals as a single radical. So that would be radical 7 and radical y. So we have radical 7y. So that's joining the radicals as a single radical. And now we're going to leave the coefficients outside. So the coefficients are 5x and y. So you get 5xy on the outside. So our final answer is 5xy radical 7y. Okay, I hope this video helps. Take care.